Now we're working on naming ionic compounds. Again, you want to use these steps. Always get in the habit of asking yourself those three questions. You really want to think through the process as you're naming or writing a formula for any compound. So we'll begin with NaF. So, is it ionic or covalent? The fact that we have sodium is a metal, so it's an ionic compound. Is there a polyatomic ion? No, we have only two elements, sodium and fluorine, so there's no polyatomic ion. And is there a transition metal? Sodium is in the first column of the periodic table. It's an alkali metal, so it is not a transition metal. So we don't have anything special to worry about. So we'll name the metal, so it is sodium. And then we will name the nonmetal and change its ending to IDE. So instead of fluorine, it will be fluoride. So sodium fluoride. Now we'll go ahead and skip down here to number 9, CuCl2. Same three questions. Is it ionic or covalent? Well, there's a metal, so it's ionic. Is there a polyatomic ion? No, I only have two elements, copper and chlorine, so it does not have a polyatomic ion. And is there a transition metal? Yes, copper is in the transition metals, which means it has a variable charge. We don't know what its charge is. So we're going to have to figure out what its charge is and put that as a notation as a Roman numeral, right here, as a Roman numeral in the name. So first I need to figure out what the charge is. So I'm going to go ahead and figure that out. I'm going to write copper and chlorine, so I have CuCl2. I can look on the periodic table and see that chlorine has a -1 charge. I have 2 chlorine atoms, or ions. That's what that subscript is telling me. So the total charge, the total negative charge of the chlorine is -2. That means that the total copper charge has to be +2 in order for these to add up to 0. There's only 1 copper atom, so the charge of copper has to be +2. So as I said before, I'm going to put that as a notation. So I'm going to follow the same rules. I'll write the name of the metal, COPPER, copper, parentheses, Roman numeral 2, and then list the nonmetal, changing its ending to IDE. So instead of chlorine, it's chloride. Again, it's important to recognize that this Roman numeral identifies the charge of the transition metal. Now we'll look at number 11. Again, think through the same 3 questions. Ionic or covalent? The potassium here tells me that it's ionic because potassium is a metal. Is there a polyatomic ion? Let me see, I have 1, 2, 3 different capital letters, which means I have 3 different elements. In this case, potassium, nitrogen, and oxygen. If I have 3 different elements, more than 2, I must have a polyatomic ion if I have an ionic compound. So I have a polyatomic ion, so I need to go to my reference sheet and find out what it's called. So let's go to our reference section and go to our polyatomic ion reference sheet, and we will see the first one right there, NO3 is nitrate. So that is the name of NO3. So now I can go back to my worksheet. And I begin naming. Oh, wait, third question. Is there a transition metal? No, potassium is not a transition metal, so I don't have to worry about a Roman numeral. So I have potassium. And then all I have to do is name the polyatomic ion, nitrate. So it's potassium nitrate. We're going to talk about one more example, number 17 here, and ask ourselves those 3 questions. Is this ionic or covalent? Well, this one can be tricky, because when I look at that, I have nitrogen, hydrogen, and chlorine, all of which are nonmetals. And there's one little curveball. There's always a curveball waiting somewhere. NH4. Let's go back to our polyatomic ion reference sheet. And if you look right down there at the bottom in bold, NH4. It is our only positive polyatomic ion. Most polyatomic ions are going to be negative. There are a few positive ones. Ammonium is the only one that you need to know. It's the only one that we're going to work with in this class. There are a few others. So you just have to recognize NH4. If you see NH4, it is going to act as a metal or as a cation, a positively charged ion. So in the case of this problem, NH4, all we'd have to do is name our ions. So that would be ammonium, and then we change chlorine to chloride. So ammonium